JEE Advanced 2025, Paper 1, Physics, Question 13. Let us visualize the physics of this problem. We have a hydrogen-like atom with atomic number Z. An electron orbits in the n equals 3 Bohr orbit. Watch the 3 allowed standing wave loops fitting around the orbit. This is the de Broglie condition. Meanwhile, a thermal neutron at temperature T also has a de Broglie wavelength. The question asks us to find the temperature at which both wavelengths are equal. Here is the question. An electron is in the n equals 3 orbit of a hydrogen-like atom with atomic number Z. At temperature T, a neutron with thermal energy kBT has the same de Broglie wavelength as this electron. The temperature is given by T equals Z squared H squared divided by alpha pi squared A naught squared mn kb. Find the value of alpha. The key concepts. First, the de Broglie wavelength of any particle is lambda equals h over p, where p is the momentum. For an electron in the nth Bohr orbit, the angular momentum quantization gives me times ve times rn equals nh bar. The Bohr radius of the nth orbit is rn equals n squared A naught over z. Combining these, the electron momentum is mee equals zh over 2 pi na naught. So the electron de Broglie wavelength becomes lambda e equals 2 pi na naught over z. For a thermal neutron with kinetic energy kBt, its de Broglie wavelength is lambda n equals h over square root of 2 meters n kBt. Now the solution. Step 1. The electron de Broglie wavelength in the n equals 3 Bohr orbit. From the Bohr model, the electron momentum is p equals zh over 2 pi na naught. So lambda e equals h over pe, which gives 2 pi na naught over z. For n equals 3, lambda e equals 6 pi A naught over z. Step 2. The neutron de Broglie wavelength. A thermal neutron has kinetic energy equal to kBt. So lambda n equals h over square root of 2 meters n kBt. Step 3. Set the two wavelengths equal. 6 pi A naught over z equals h over square root of 2 meters n kBt. Squaring both sides and solving for t, we get t equals h squared z squared over 72 pi squared A naught squared mn kb. Comparing with the given form, alpha equals 72. The correct answer is alpha equals 72. Here are some important tips. Tip 1. In the Bohr model, the electron de Broglie wavelength in the nth orbit is simply 2 pi na naught over z. This is a direct consequence of the standing wave condition. Tip 2. For thermal neutrons, the kinetic energy is kBt, not 3/2 kBt. The question explicitly states thermal energy equals kBt, so use that directly. Tip 3. When comparing wavelengths, always square both sides to eliminate the square root. This avoids sign errors. Tip 4. The factor 72 comes from 8 times n squared, where n equals 3. That is 8 times 9 equals 72. Recognizing this pattern helps you generalize for any orbit. Like and subscribe for more JEE Advanced solutions at MAGPIEHUB. See you in the next video.